going to probably say, like, how come you didn't teach this earlier? And it's because we didn't know derivatives yet. So check it out. Look how easy this is. This is called, you pronounce his name L'Hopital. Sometimes they say hospital, but it's L'Hopital. He didn't even create this, by the way. L'Hopital found this in the real person who created L'Hopital's rule, wrote it in a journal, and then L'Hopital just found it. So it says, remember how we used to do these limits? The first thing we would say is, can you do direct substitution? No, because you get a zero in the denominator. So then what would you say? Well, you can factor the numerator, because that's the difference of squares. Bless you. Did I hear someone sneeze? Okay, maybe I'm hearing things. X plus 2, x minus 2, and then over x minus 2. And then what cancels out? Bam! The x minus 2's. And now you can do direct substitution. 2 plus 2 is 4. Okay. L'Hopital's rule. What does L'Hopital's rule state? L'Hopital's rule states that if I have 0 over 0 when I do direct substitution, so I'm going to first do limit as x approaches 2 of x squared minus 4, and you get 2 squared minus 4, which is 0. Then I'm going to write limit as x approaches 2, this is for the denominator, of x minus 2, and I get 0. So I would have gone 0 over 0. That's indeterminate form. Indeterminate form. There's so many different types of indeterminate form, but this is a primary one that we're going to be focused on. L'Hopital's rule states that we can take the derivative of the numerator, limit as x approaches 2. So as long as we don't get a 0 again, so the derivative of the numerator is 2x, and we get the derivative of the denominator, 1. And as long as we don't get 0 over 0, that will be my answer. And check it out. 2 times 2, 4. And it worked. That's the same thing we got last time. Cool, right? Now, the real proof, you probably need to be a graduate student to understand the real proof. Here is the Wikipedia proof, which we shouldn't take full, like we shouldn't always do that. But I vetted it, and it looks like it's legit. And yeah, so when can I use L'Hopital's rule? You can use it whenever you get infinity over infinity or 0 over 0. Why did my infinities look so ugly? I'm sorry. Usually I do it with little doubles. These are the main ones. There's others. There's infinity, minus infinity, 0 raised to the 0, all the other ones. But the only ones that we're concerned about are these two. Really, the only one we're really concerned about is that one. With this one, we will let end behavior do the work. We will let end behavior do the work. Do the work. All right, so when can we use L'Hopital's rule? If we get 0 over 0. Cool or not cool? Cool. Let's go to the next page. This is coming from the course and exam description. And we're going to go slow. We're going to go slow. Look at the numerator. Limit as x approaches 0 of 7x minus sine x. And when I plug in a 0 in there, 7 times 0 is 0, and sine of 0 is 0. Limit as x approaches 0 for the denominator, x squared plus sine 3x. Again, if I plug in a 0, 0 squared is 0. 3 times 0 is 0. Sine of 0 is again 0. So this is an indeterminate form. You get 0 divided by 0. Does that make sense to you guys? Because we get 0 here and 0 here. So can I use L'Hopital's? Yes. What does L'Hopital say? Just take the derivative of the numerator and denominator. What's the derivative of the numerator? 7 minus cosine x over 2x plus or minus. Plus, what's the derivative of sine 3x? Cosine 3x times 3. Have I lost anyone? Let's do direct substitution and see if we get an answer. And we do. I'm going to put equal sign. Cosine of 0 is 1. 7 minus 1 is 6. So where did that come from? Let me write good notes. 7 minus cosine of 0. And for good notes, cosine of 0 is 1. And I'm dividing that by, as it says, 2 times 0 plus 3 cosine of 0. Cosine of 0 again is 1. 1 times 3 is 3. What's 6 divided by 3? And there it is. There's my answer. supposed to be a denominator there. How do we feel, guys? Pretty easy? Yeah. Don't worry, we will talk about. All right, so here we go. We got another one here. I didn't put the percentages. I don't remember if that one didn't have it or if I just didn't put it in there. Let's do it together first. I'm going to go as numerator first. Limit as x approaches 3 of tan x minus 3. That is tan of 0, which is 0. Let's do the denominator. Limit as x approaches 3 of 3e to the x minus 3 minus x. So let's see what we get. 3e to the 0 minus 3. E to the 0 is 1, and 1 times 3 is 3. And again, I get 0. And I'll slow down. Now, ask me. Dime. That's Spanish for tell me. We're okay so far, guys? All right, check it out. I get 0 over 0, so can I use L'Hopital's rule? Here we go. Limit as x approaches 3. Do you remember what the derivative of tan is? Perfect. Secant squared of the argument, x minus 3, over, what's the derivative of 3 to the x minus 3? The same thing itself. 3e to the x minus 3 minus, what's the derivative of x? 1. Now I do not get 0 over 0. Now I get something. If I plug in a 3 into secant, I get secant squared of 3 minus 3, which is 0. Secant of 0, remember secant's the reciprocal of cosine. Secant of 0 is 1, so I get a 1 in the numerator. In the denominator, 3 minus 3 is 0. E to the 0 is 1. 1 times 3 is 3, so I get 3 minus 1. So my answer is 1/2. Notice they have a 1/3 there because they want you guys to pick it. Cool, right? Let's see. Don't worry, we're going to do a real free response question. Check it out. Our first one. I think this is our first legit one. First legit FRQ. These are exciting times. This question that you're looking at is from the 2018 AP exam. Question number 5, no calculator. We're finally reaching the point where we can do free response questions on our own. You guys ready? All right, look at this one. Letter A. Let f be the function defined by, and then define it by that. Find the average rate of change of f on the interval 0 to pi. All you have to do, you've been doing this since your Algebra 2 days. All you got to do is y2 minus y1 divided by x2 minus x1. So here it is. So all you're doing is this. You're going f of pi minus f of 0 divided by pi minus 0. That's all you're doing, guys. I'm going to come to the side. I'm going to write what f of pi is. F of pi equals e to the pi cosine pi. What is cosine of pi? Positive or negative? Negative 1. So negative e to the pi. F of 0 equals e0 cosine 0. Don't worry, guys. I'm slowing down. Cosine of 0 is 0. Sorry. Cosine of 0 is 1. And e to the 0 is 1. What's 1 times 1? 1. There it is. I'm going to come back. I'm going to go negative e to the pi minus 1 divided by pi. Done. That's your answer. In a little bit, we'll see our key, see how good we are. How do we feel? Have we done anything crazy? Okay. Letter B. What is the slope of the line tangent to the graph of f at x equals 3 pi over 2? What must I do to get a slope? Take a what? Derivative. What rule do I got to use for my derivative, guys? Which rule? No, not quotient. Product. See, you got a product. So here we go. I'm going to go slow, guys. F prime of x equals first times derivative of the second. What's the derivative of cosine x? Negative sine x. Plus second cosine x times derivative of the first. What's the derivative of e to the x? E to the x. What I see, here's what I see. Negative e to the x sine x plus e to the x cosine x. I'm going to make life simpler. Catch up to here. I see that both of these terms have an e to the x on them. So can I factor that out? So here it is, guys. F prime of x equals, I'm going to factor out the e to the x, and I'm going to write the cosine first because it's positive. I think it's easier to look at the positive one. Cosine x minus sine x. Okay, I'm done. I'm going to plug in a 3 pi over 2. F prime of 3 pi over 2 equals e to the 3 pi over 2. We don't know what that is. That's some number. Cosine of 3 pi over 2 minus sine of 3 pi over 2. So e to the 3 pi over 2 times, and I'm going to wait for you guys to catch up. It's a little bit of pre-cal, guys, but it's not even extreme pre-cal. It's like baby pre-cal. What is cosine of 3 pi over 2? 0. What is sine of 3 pi over 2? 1 or negative 1? Negative 1. So you have 0 minus a negative 1. So you just get 1 times that. So the answer is e to the 3 pi over 2. See? Ask me. Ask me, guys. I make mistakes too. Tell me where I went wrong. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. Minus a negative 1 turns to a positive. So there it is. E to the 3 pi over 2. Are we okay, guys? All right. Here we go. We do not know enough for letter C yet because we haven't even talked about analysis of functions. So not here yet. Not here yet. We will be very soon. Child, we haven't done any L'Hopital's rule for this pre-response question. Why do we learn L'Hopital's then? Here it is on letter D. By the way, we can only use L'Hopital's when the function is differential and continuous, right? The rules for differentiability, because that's how we take a derivative. Remember, if you're taking a derivative, you got to be continuous and differentiable. All right, let G be differentiable functions such that G of pi over 2 equals 0. The graph of G prime, the derivative of G, is shown below. Find the value of that, or state that it does not exist. Justify your answer. Limit as x approaches pi over 2 of f of x equals f of pi over 2, which equals, I don't know what that is. What was it? I just plugged in pi over 2 in for f. I'm suspicious that we're probably going to have to use L'Hopital's rule, so we're checking to see if I get 0. I'm just plugging in pi over 2 into this guy.
Oh, into that.
Yeah, because that's f of x, right? So we're going to go e to the pi over 2 cosine pi over 2. Look, you get 0, guys. And then they just told you, look at that right there. Limit as x approaches pi over 2 of g of x equals 0. Chop, how did you know that one real fast? They just told us. They literally just told us right here that g of pi over 2 equals 0. So there it is. So we're going to say, let's see, what are we going to say? Since f and g are differentiable and continuous, and since the limit as x approaches pi over 2 of f of x over g of x is of indeterminate form, comma, we may use L'Hopital. Period. Okay, so don't worry. We're going to catch you up. You can only use L'Hopital's if you're continuous, if you're differential, because we're taking derivatives. How do I know that G is differential and continuous? What is this? It's G prime. The only way you're going to have a derivative is if G was continuous and differentiable. Now, I know what you're looking at. You're looking at pi over 2, and you're like, chop, that's like a corner. G's not differentiable. Guys, G prime is not differentiable at pi over 2. G is. G is a nice smooth curve. because you have a value everywhere. There's no jump there. It's continuous. So G itself is continuous. Now, if you were to try to take a derivative of G prime, then yeah, G prime, you can't take a derivative of powers. Are we okay? Tell me, guys, because I can't read minds. Okay. Because G has a derivative graph, you see the derivative graph? G is continuous and differentiable everywhere. That's it. That's it.
Oh, okay.
If you were to tell me what G prime prime of pi over 2, G prime prime of pi over 2 is undefined. Well, actually, because that's a corner or a cusp. But that's a corner or a cusp on G prime, but not on G. Okay, here we go, guys. Here we go. All I'm going to go is go limit as x approaches pi over 2 of f prime over G prime. I already have the derivative from earlier. What's my derivative from earlier? It's up here. Here's my derivative. I'm going to use this guy right here. Yeah, pi over 2. Hey, don't yawning. Get some sleep, guys. E to the pi over 2, parenthesis, what is cosine of pi over 2? 0. And sine of pi over 2 is 1. You got to know a little bit of pre-cal, guys. Not even extreme. Just a little bit. Over G prime. Well, here's G prime. What's the value? 2. So my answer, negative e to the pi over 2 over 2. Yeah. Negative because of that minus. You're multiplying by negative 1. Because this is my G prime graph. And G prime of pi over 2 is 2. No, ask. Ask. Ask, guys. I cannot read minds. Okay. Let's see how I have not looked at the rubric, guys. Obviously, I looked at it in years past. I have not looked at it today. I did print it out, but I did not look at it. Here's a rubric. Every free response question is worth 9 points. All of them. Letter A. It was only worth how many? 1 point. Did we get the point? Yes. Letter B. Look how they broke it down, guys. They broke down letter B by the derivative and the slope. So if you can get the correct derivative, that's a point. And then if you can get the slope, that's another point. Did we get this as my derivative? Ex cosine x minus e to the x sine x. We factored out the e to the x. Ours is better, I think. But no big deal. Cool or not cool? So we got the point for the f prime. Did we get the point for the slope? Did we get e to the 3 pi over 2? Bam, you got it. There it is. You got both points, guys. Don't worry about letter C. We're not there yet. You have to find critical points and all that good stuff. We're not there yet. Look at letter D. Letter D was worth 3 points. We found that the derivative as x approaches pi over 2 was 0. So we got that point. Or because G is differentiable, G is continuous. We studied F and G. That's fine. We're good. We know that the G of pi over 2 is 0. By L'Hopital's, did we get this answer? We got all 3 points, guys. Look. They give you a point for G is continuous. We went overboard. We said F as well. We got it. We found where the limit equals 0 for that one. We applied L'Hopital's rule and we gave the answer. Notice the little note, max 1 of 3 if no limit notation attached to a ratio of derivatives. Just notice that. So look, we just did our first free response, guys. We got 3 points. 3, 4, 5, 6. If you get 6 out of 9, you're in good shape. And we still haven't done letter C, but we don't know that yet. Cool or not cool? Okay, let's keep going. Look, now these are just coming from delta. This is what you're going to see today. The graph of the function f is shown below. Determine the value of in simplest form. Okay, get in the habit of doing this. Break up the numerator and denominator. Limit as x approaches negative 2 of 4x squared plus 8x equals 4 times negative 2 squared plus 8 times negative 2. Don't worry, I'm slowing down. Negative 2 squared is 4. 4 times 4 is 16 minus 16. So I got a 0 for the numerator. Now I'm going to check if I get a 0 for the denominator. Limit as x approaches negative 2 of 3 times f, 3 times negative, 3f of x. 3x, close it, minus 3. And let's see, equals 3. And then I'm plugging in a negative 2. 3 times negative 2 is 6. So f of negative 6 minus 3. Here is f. Is this f? Yep, that's f. This is f. So I'm going to go to negative 6, and it looks like it is 1. So 3 times 1 minus 3, so I get a 0. And I'll slow down. F is continuous and differentiable. It's whatever that derivative is. It's whatever the slope of that line is. So we're good. And we get 0 over 0. This limit, it gets 0 over 0. It's indeterminate form. So can I use L'Hopital's? Yes, here it is. Using L'Hopital, we get limit as x approaches negative 2. 4x squared, the derivative of 4x squared is what? 8x plus 8 over 3f prime of 3x, chain rule guys, times 3. So let me rewrite it again. Limit as x approaches negative 2 of 8x plus 8 over 9f prime of 3x. All right, let's see what that is, guys. 8 times negative 2 plus 8 over 9f prime. 3 times negative 2 is negative 6. Okay. I'm slowing down. I multiplied it. Oh, you're good, you're good. All right, so I have negative 16 plus 8 over 9 times whatever this slope is. It's easy to count. Just go right here, guys. It looks like it's 1. 1 up, 1 right, 1 up, 1 right, 1 up. Yep, it's 1 times 1. So negative 8 over 9. That makes sense, guys? Okay, don't worry. We're going to do a few more together, and then we'll set you guys loose. Today's L'Hopital's is pretty straightforward, I think. Okay. All right. Given the selected values of the function f and its derivative in the table below, determine the value of the limit in simplest form. Again, get in the habit of doing the numerator and denominator. Limit as x approaches 2 of 2x squared minus 8 equals, more than likely it's going to be 0 because it's just coming from the L'Hopital's booklet. 2 squared 4, 4 times 2 is 8, 8 minus 8, 0. Yep. Limit as x approaches 2 of 2f of 2x plus x equals, let's see, 2f of 4 plus 2. F of 4, I'm looking right here. F of 4 is negative 1, so negative 2 plus 2 equals 0. Yep. Can I use L'Hopital's rule? Yes. Limit as x approaches 2. What's the derivative of 2x squared minus 8? 4x over, and then I'm going to do chain rule, guys. 2f prime of 2x times 2. So it's going to turn to 4f prime of 2x plus 1. Does everyone know where that plus 1 came from? All right. I'm going to plug in a 2. Bless you, bless you. 4 times 2 is 8. 4f prime, 2 times 2 is 4 plus 1. I'm going to get f prime of 4 right here again. It looks like it's negative 2. So 8 over 4 times negative 2 plus 1. So negative 8 plus 1, negative 7. 8 over negative 7. How do we feel, guys? Not bad, right? Actually, that's it. That's the last one. So you just have a quick delta assignment, guys. It shouldn't take more than 20, 25 minutes. So you should have a lot of downtime. So that's it. Take care of the delta and we're done. Good job, guys. What's up?